Welcome to the lecture on Introduction to Welding Distortion. So, we studied about the residual stresses which are developed in the welding, and the associated topic which is further needed to discuss is the welding distortion. So, many a times we see that when we do the welding, the parts are distorted, the welded specimen is distorted, and there are different types of distortion, and there are reasons for these distortions to occur. So, first of all, we will be acquainted with why this distortion occurs, and what are the parameters which affect these distortions, and then slowly as we move towards the other other portions to discuss the distortion, we will talk about the types of distortions, the different types of distortions, and what is the how we do the quantitative analysis of the distortion which occur in welding, and how to get rid of these distortions or how to control the distortion. So, that we will discuss. So, as we know that distortion means any unwanted physical shape change in a welded structure, that is called distortion. Distortion means it is becoming out of shape. So, it is no longer you can use them. So basically if the structure is distorted, its usefulness will be affected. You cannot have the same value of that component as has been if it would have been undistorted, or it would have been in a proper shape. So, many a times what happens that when you have the distorted shape, then you have to do some measures to rectify it, and that basically also involves certain costs. So, you have to spend resources for correcting it, and what has been seen that the cost of correction or cost of making this shape in a proper manner. So, that is becoming quite high as compared to the original cost of the machine itself. So, so that basically adds to the the ill effects of the distortion. So, basically you must have the proper measures to minimize the welding distortion, so that you have a minimum effort required to rectify those distortions after welding. Now, distortion is caused by non-uniform expansion and contraction of weld metal and adjacent base metal during the heating and cooling cycle of the welding process. So, what happens that as we know that when your welding process is going on, so the heat will be dissipated towards the sides. So, if you talk about the sides, the heat will be increasing. So, the heat when it is dissipating, the temperature on the side will increase, and so there will be expansion. Similarly, when if you talk about the region or the portion which is along the line of welding, and if you take a position which is behind that welding spot. Now, on those areas, as we are moving away from the from that place, so that starts cooling. So, that leads to basically the contraction. So, basically you have a complex state of stress which is developed. You have somewhere expansion, somewhere contraction. So, you will have compressive stress or tensile stresses developing. Now, all these things if if they are interacting, so that many a times lead to the formation of these distortions. So, if you talk about the change in the volume of the material, so what we see that you have in 3 stages the volumetric change takes place. So, if you recall the change in the volume of the material. So, one is in that superheated state. So, from there it is coming to liquidus temperature, another will be during that solidification, and then later on you will have during the solid stage. So, you have 3 stages of expansion. If you recall, then what you see that for every 100 degree C you have about 0.8% of volumetric expansion in that superheated state. So, the superheat which will be extracted. So, for extraction, by extraction of superheat, you have about 0.8% of volumetric change. Similarly, when you do the solidification, if you talk about mild steel, so in those cases during the solidification the volumetric change will be close to 3%. So, during the solid state it is about 7 to 7.5%. So, altogether if you look at it is in the range of 11 to 12% or 11 to 15%, which is the range in which these volumetric expansion is taking place. Now, what happens that that may be taken care of by the plastic deformation. So, so what you see that in your stage 1 where you have the extraction of superheat. So, there it is it is of the order of 0.7% or 0.8% per 100 degrees C. Similarly, if you go to stage 2, so where you have the solidification shrinkage or phase change. Now, in that your shrinkage is about 3%, and if you go to stage 3, so which is the solid shrinkage, so that is taken care of by providing that other type of allowances in case of casting, but here anyway it is taking place. So, this solid shrinkage, that is normally of the order of 7.35%. So, so this way what you see that you have altogether close to 11 to 12%, or even it may go even for some materials may go even of the order of 15%. So, now if these are to be accommodated, so what happens that that results in the development of internal stresses, and if that is in the if that, so that will result in the plastic deformation if that exceeds that yield stress. So, and even that result into tearing of the material. So, that is the effect of these changes which take place during that during that solidification of the material. So, what we do, we also give further treatment, thermal or mechanical treatment also. So, what we see that that leads to the development of the internal stresses, and that may result into the distortion of the welded specimen. So, coming to the effect of the or the factors which are affecting the distortion in the welds. So, you have certain parameters which basically affect the distortion in the welds, and among those factors you have the material properties. So, there are different material properties, and each of the material property may have a positive or a negative contribution towards the distortion which is caused in the welded specimen. So, the properties which are of interest which affect the distortion of the welded specimen are like coefficient of thermal expansion, thermal conductivity, yield strength, modulus of elasticity, and then you have other welding processes and procedures like you have all these welding amount of weld metal, and then you have other parameters we will be discussing. So, if you come to the effect of these parameters, so material properties say, so if suppose you have the coefficient of thermal expansion. So, if you recall, this is the property which talks about the the change in the dimension of the material as the temperature is increased. So, if you so this will be the the measure of expansion and contraction. So, that if it is more, so it will either expand more or it will contract more, because as per the change in the temperature. So, if it is greater, so if the greater be the coefficient of thermal expansion, so that will more likely you will have the more distortion. So, greater be the coefficient of thermal expansion of material. So, then so larger will be the chances of distortion. So, that is very obvious that as the coefficient of thermal expansion will be more, there will be a large amount of distortion in those cases. Next is your thermal conductivity. So, thermal conductivity is the property of the material by which the heat is allowed to pass through it. So, if the thermal conductivity will be more fast, the heat will be allowed to pass through the material. So, how readily the heat will be allowed to spread through the material, that will be indicated by the value of thermal conductivity of the material. So, if your thermal conductivity of the material is low, in that case there will be more thermal gradient. So, it will take larger time to pass through. So, there will be more thermal gradient. If the thermal gradient is more, it means that will be likely to produce more distortion. So, and if the thermal conductivity on the contrary is higher, in that case it will quickly allow to pass the heat through it. So, thermal gradient will not be more in the material. So, accordingly your distortion of the material will be smaller. So, what we see that if you have high thermal conductivity of the material, there will be less chance of distortion, and certainly the case will be opposite if you have a low K. So, in that case you have high temperature gradient. So, you have so high chances of distortion. So, that will be the effect of the thermal conductivity of the material. Next property is the yield strength. Now, if you talk about the yield strength, so the higher will be the yield strength of the material. So, greater will be the residual stresses available for causing the deformation. So, higher be the yield strength of the material, greater will be the residual stresses. Available for distortion, for causing distortion in fact, because that much of stress it can accommodate up to that stress. So, that is available as the residual stresses, and then that can that, so your chance of distortion will be that way higher. If you talk about the modulus of elasticity, so as we know that this property is also important because it talks about the rigidity of the or the stiffness of the material. So, if the material has a high modulus of elasticity, or if it is more stiff, it will try to resist the deformation. So, higher will be the modulus of elasticity, it will more it will be resisting the deformation, and so less will be the deformation. So, higher will be modulus of elasticity, lesser will be distortion. Now, so these are the typical material properties which basically will be decisive and will tell you whether the distortion will be more or less. Now, coming to the influence of other parameters, like you have welding process or the procedures. So, if you talk about the influence of welding processes and procedures. So, other than these physical properties of the material, other factors are also important which determine the extent of deformation, distortion in the welded specimen. Now, what are the types of welding processes, what are the procedures of doing the welding, because ultimately when we talk about the welding processes or procedures, so basically we are dealing with the hot metal which is accumulated at a place, and its design of that weld pool, how the weld pool is, what is the so that is a concentrated basically heat source, and then how you are moving, how much it is affecting, how long its effect is there. So, for more time its effect will be there, more will be the effect on distortion. So, that way it affects those distortion which is going to come on the material. So, basically overall the distortion, the amount of welding distortion, it will be depending upon the volume of the heated metal. So, what is the volume of the heated metal and how its distribution is there, how the bead shape is there. So, the bead shape will also be important on the distortion which is occurring during that welding. Many a times you may have with certain type of bead shape or so, or the joint which you are making, you may have uniform shrinkage and you may have either non-uniform heating and cooling also. So, that will lead to different values of the distortion, different way the distortion may be coming up. So, the volume of the heated metal, so that way volume of heated metal is a very prominent factor which will be talking about the extent of distortion in welding. So, volume of heated metal will be depending upon many factors. So, those factors are basically the type of welding process which you choose. So, if you talk about the welding process, so what happens that what kind of welding process you are choosing, what is the whether it is a very concentrated heat source or you have a distributed heat source sort of thing. So, whether it is concentrated or not very concentrated. So, in that this is important that if you have a concentrated heat source, so in those cases it is likely that it will give you lesser amount of distortion. So, if you talk about the welding process, so in that if you have a high concentrated heat source, that will provide you lesser amount of distortion. So, high concentrated heat source provides lesser distortion. Then if you take the welding speed higher, that also gives you the less distortion. So, high welding speed, that gives you less distortion, because if the speed is higher, so spread will be less, and in that case the distortion will be less. So, similarly if you have deep penetration, in that case the distortion will be less, that gives you less distortion. Now, many a times we go either for one pass weld or multi pass weld. So, the single pass weld will give you lesser distortion than the multi run welds or so that way single pass welding gives less distortion. Than multi pass welds. So, this is the effect of the welding process, which and where this way these parameters will be affecting the extent of the welding distortion. Then comes next is the amount of weld metal. So, if your amount of weld metal will be higher. So, normally we should try to have the weld metal amount to be minimum, because that basically is the heat source or the content of the heat which is there. So, minimum is the heat weld metal, if it is, which basically should be sufficient to do the satisfactory welding process and satisfactory quality of the weld bead. So, if the amount is smaller, so or kept minimum, so that is basically better for a for the lesser distortion. So, that way mostly we should try to have the minimum amount of weld metal. Coming to the welding speed, so that we have already seen that welding speed should be higher, so that your distortion is smaller, but then you must have that also in mind, because this is a process of solidification also going on. So, the solidification has to be in the proper orientation, and you must have the proper care to avoid any kind of defect because of these high welding speeds, I mean more than required, because if it is more in that case, because shrinkage is taking place. So, that should not create any kind of defect such as centerline shrinkage or weakness of the material. So, the welding speed although should be high, but then that also has to be taken into consideration. Then edge preparation and fit up. So, edge preparation and fit up is also important, because it has to be such that your amount of weld metal should be minimum, and also it should be uniform, so that you have uniform shrinkage, or you have consistent shrinkage around the joint. So, that way your edge preparation and fit ups that should be designed in such a manner that these uniform shrinkage as well as you have the consistent shrinkage around the joint is there. Then you have other effect which is also important, is the welding procedure. Now, if you talk about the welding procedure, so in that case you have single pass or multi pass, or you have high speed weld. So, that way you have this is the welding process, but apart from that you have other welding procedure, like we talked about the back step welding, or you have the skip welding procedure. So, these basically are used to so we have talked about in earlier lectures that the back step welding or the skip skip welding. So, these are the ways to minimize the residual stresses. So, basically we should try to see that these procedures should be adopted to minimize the the residual stresses, and basically that only will create the distortion. So, that also plays an important role, these welding procedures. to minimize that distortion in the weld. So, it should always, so basically in that the precaution which has to be taken is normally that you should always start the welding from a clamped end and move towards the free end. It is not that you should start with from a free end and then go towards the clamp end, because then there will be have the restraint, So basically that will again, that restraint will create large amount of stresses, and that stresses may create distortion in the workpiece. So basically what you see is that what kind of process you are taking. We do in the case of skip welding, where we are skipping the tack welds, we do in some region, and then we leave one or two, and then further we are doing that welding. So that also is done. So basically these processes which are adopted, they are with an aim basically to reduce the stresses, and so once the stresses will be reduced, accordingly the distortion will also be less. So this is about the distortion or introduction to the distortion. If we talk about the different types of distortion, basically one is, if you talk about the different kinds of distortion in welding. So you have so if you talk about a particular weld. So what happens that if you have, suppose you have a butt weld which is going on. So if suppose this is the bead, so this is your weld bead which is there on this sheet. So what happens that there may be distortion in different way on this specimen, and that will be mainly in terms of shrinkage, or in terms of the angular distortions, or it may be the bowing, or it may be the twisting. So these are the different kinds of distortions which take place, because as you know that along the longitudinal direction, if you look at, you have the stress pattern goes like this, and then it will be coming in the negative direction here. So this way it will be going. Now what happens that when you, as we know that since the weld metal which is there, so it is in liquid state and it has to solidify. So you have the shrinkage which take place either along the longitudinal direction or along the transverse direction. So the shrinkage which take place along the longitudinal direction, so that will be termed as the longitudinal shrinkage. Similarly, you will have the shrinkage also in the transverse direction, so that will be your transverse shrinkage. Then you have distortions going out of shape, so they are there. So you have angular distortions which take place, you have different types of welds. So you have the angular distortion at some angle, it will be bowing, it will be bending or so. So the distortion which is there normally in the case of fillet welds or so. So or anywhere you have the angular distortion taking place in terms of angles also you measure. So we call it as the angular distortion. You have the bowing or bending also, which is there, that is also a type of distortion which take place in this welding. Then the other kind of distortion is the twisting or buckling. So that also is one of the distortion. You might have seen that many times if we do the welding on the thin sheets or so they buckle or they twist. So basically mostly when that also depends upon the thickness of the parent material many a times. So many a times that kind of distortion which is taking place, that is your buckling or twisting. So we will have the introduction about the different types of welding distortion, how it looks like and how can it be quantitatively we can discuss about those distortions. So we will have the discussion on these topics in our coming lectures. Thank you very much.